Welcome to today's training, introducing the new DJI Mavic 3 Enterprise Series, your everyday commercial drone. We'll be running over a product introduction, a product comparison, and then getting into global use cases. First off, let's just look at the Mavic 3 Enterprise Series at a high level. If someone's asked you about it, this is probably the most key information you're going to need to know right on one slide. So we obviously have two versions, as you can see, the Mavic 3E and the Mavic 3T. Throughout the presentation here, we'll refer to them as M3E and M3T for short, and you might come to refer to them as the same. The Mavic 3E is the entry-level commercial drone, has a 4/3 inch camera and a mechanical shutter. And this is a drone within the DJI Enterprise product line that can fulfill basic needs for end users on the enterprise side. The Mavic 3E with the RTK module would be an entry-level surveying drone because it adds the time sync and RTK capability. And ultimately, the Mavic 3T is our new entry-level thermal drone, which is an improved platform from the Mavic 2 Enterprise Advanced. Some key ideas to think about here, obviously the portable design, the ability to fit in a backpack alongside other equipment and items, a 45-minute maximum flight time, the large wide camera, the 640 by 512 thermal camera, up to 56 times hybrid zooming, the O3 Enterprise transmission, and then the optional RTK module and speaker accessories from the DJI side. So once again, if you're looking for one slide on the Mavic 3 Enterprise, and we're obviously going to get a lot further into things today, these are some key headlines to remember. So light and portable folds the same as your typical Mavic series. Obviously, being able to put it in a car, a command vehicle, a backpack is very useful, and weighing in at under 1,000 grams. Two different cameras here. The M3E has the wide and the tele camera. The M3T has a wide, a tele, and a thermal camera. We'll jump into those sensors a bit more in detail here, but key thing to remember here, we have the same tele camera on both systems, but then different wide cameras, and then the M3T adds a thermal camera. So looking at the M3E Wide Camera, we mentioned it's a 4/3 inch CMOS sensor, takes 20 megapixel photos, large pixel size at 3.3 ohms, increasing daily operation time. So once again, if we're having less light out, the larger sensor size is going to help us still take a quality picture. Mechanical shutter, and just a note here, that is a setting within the Pilot app. So if you want to use a mechanical shutter, do need to turn that on. That helps avoid rolling shutter effect. Specifically, you can think about mapping side. Obviously, the drone's flying as it's taking photos in most cases, so very useful. And a shutter life of 200,000 uses there. Very low minimum photo interval of 0.7 seconds, and also has the option for a smart low light photo. Utilizing the RTK module is what enables you to achieve centimeter level mapping accuracy without using GCPs. Obviously, most folks on the surveying side will still want to verify that data with checkpoints, but a big time saver not having to place a large number of GCPs across a scene and still be able to achieve that consistent centimeter level accuracy. As we mentioned before, telecamera is the same on both. It's a 1/2 inch CMOS sensor, 12 megapixel photo, 162 millimeter equivalent focal length. So when we say 56 times hybrid zoom, 1 to 7 times is digital zoom of the wide camera, and then 7 to 56 times is digital zoom of the tele camera. So you'll notice when you get to 7 times, the image quality will improve a bit as you're simply hopping over to that second camera. With the M3T side, that tele camera syncs up with the thermal camera, so you have 28-time synchronized zoom between the thermal and the visual cameras. When you go into the zoom, you'll notice the thermal zoom starts at 2 times. So to line it up with the visual camera, you still have full thermal resolution, all the way zoomed out though. And you'll notice when you're zooming in with that synchronized split screen zoom, It's a smooth zoom from both cameras. There isn't a jump on the thermal side, so some nice work on the engineering side to make that happen. For the M3T Thermal Camera, 640 by 512 at 30 hertz, so industry standard there on that thermal camera. And that is alongside the half-inch wide camera as well. So obviously with having to fit the thermal camera in, the wide camera doesn't have as much room, so it has not a mechanical shutter, but still gives you the option there with the thermal and the wide and the zoom. Circling back to the Mavic 3E here, jumping a little more into the surveying efficiency. Obviously, if you want that centimeter level data, probably will be using the RTK module. So flight time with that RTK module has been improved to 42 minutes. 0.7 second shutter speed allows you to fly at 15 meters per second during the mapping mission, and ability to capture over 2 square kilometers in a single flight. We know we have global users here, so it varies where you are in regards to how high you can fly for a mapping mission. You can see the information at the bottom of the screen here, talking about the comparison here was at an altitude of 185 meters, 80% front overlap, 60% side overlap, that max 15 meters per second flight speed, and landing with 11% battery remaining. So you can see the M3E, the P4R, and the P1. Obviously, the P1 certainly still reigns supreme when we look at larger areas and mapping efficiency, but you can see that the M3E still does a really good job and improves on the ability of the Phantom 4 RTK based on some of these highlighted specs above. Also, the Enterprise series offers a new 100-watt charging hub, so it only takes 70 minutes to fully charge a single battery, and that's talking 0 to 100 here. And when you're in the field with about 4 sets of batteries, you're looking to fulfill a full day of flight operations there, where you can complete a flight, have a battery on charge, and continue operating throughout the day to map a location out. Getting into that centimeter level mapping accuracy a bit further here, TimeSync 2.0, you've seen that with the P1 as well, but essentially takes into account different parts of the drone, including the flight controller, the center of the camera, to give you centimeter level accuracy within those photos, so that corrections data is automatically written. Mechanical shutter, obviously helping out with no rolling shutter effect when the camera is moving alongside the drone. And on the M3E camera side, that's going to be calibrated with internal parameters when it's produced, and those internal parameters will be written in the XMP information of each image. If you haven't gotten into the metadata on the photo side, you can always right-click, open an image, and text edit to find that XMP information, or use something like EXIF tool. But circling back on the mapping accuracy here, that is relative to GSD, ground sampling distance, and the M3E ground control point free accuracy is about 2 times that of the GSD. For example, if we're flying at 100 meters, our GSD is about 2.7 centimeters, so accuracy is within 5.4 centimeters. So similar accuracy level overall to the P4R or M300 and P1. Getting into transmission side a bit, we have a 4 antenna design on the RC, 2 transmitters and 4 receivers, range of 9 to 15 kilometers with low interference, and about 1.5 to 3 when in an area with strong interference, with FCC guidelines and referred to that comparison there. The 4G transmission will be supported through firmware updates, and unfortunately, that will not be supported in the US market. On the safety side here, you can see omnidirectional obstacle sensing, so wide angle vision sensors on different sides of the aircraft to give us omnidirectional information. In the pilot app, you'll be able to adjust that specific distance that you'd like the drone to warn you at and stop at as well. Another feature available here is the advanced return to home. So you'll see in the pilot app settings, you have the ability to do the advanced return to home, or regular. So with that advanced return to home, the aircraft will take the optimal route back using those omnidirectional obstacle sensing. Once again, that is an option, though. You can do the typical go up to the return to home altitude and come home if you would like to. APAS 5.0 stands for Advanced Pilot Assistance System. So once again, another option in the settings, but for example, if you're trying to fly at the pole here, in this case, the drone would automatically navigate around it when you had the APAS 5.0 setting enabled. So once again, your option there to go around the object or to simply stop, and kind of more of a traditional obstacle setting there. Some of the accessories, the RC Pro Enterprise, looking at a 5.5-inch screen, up to 1,000 nits, 3-hour battery life. There is no external battery on the back of that, just to clarify. Has a built-in microphone for use with the speaker, supports the DJI cellular model, once again, not supported in the US. 1.5 hours to fully charge, and you can also charge it while operating. Supports mini HDMI out and screen recording as well. RTK module side, this is a detachable RTK module, weighs 20 grams. So nice job by the team optimizing the size of this and efficiency of cooling to elongate the flight time. Supports network RTK, custom network RTK, and DRTK2 mobile station. So you have the option there if you want to use your N-trip network, which is my favorite when possible with the internet, makes life a bit easier, or set up that DRTK2 for use probably over a known point, but once again, depends on the workflow at the end of the day. Photos do support writing RTK providers information as well. So circling back on that metadata before, if you would open it up and you've connected to an N-trip network, you'll be able to see all that information included in the metadata. On the speaker side, overall louder volume compared to the preceding speaker, supports both recording and looping whatever you have played back. A new interface overall on the UI side, and it's very easy to use. So you can either record and then broadcast using the RC Pro Enterprise. You can do text to speech or upload a file for that speaker. Common questions on that, just a reminder, it is a one-way speaker, and it is something you would talk and then it would transmit, but you can also loop that as well or have files saved to play as needed. DJI cellular model, drone and the RC support 4G enhanced image transmission, and the dongle on the remote controller also can be used for RTK, Flight Hub 2, or live streaming. Getting into some of the professional software on the DJI side, the Mavic 3 Enterprise series supports DJI Pilot 2 as our ground control software. So the RC has that built in. So when you're updating your RC, Pilot 2 app will update as well. Supports multiple mission planning options, waypoint, mapping, oblique, and linear. So if you're familiar with using the Pilot 2 app before with a different system, you'll have very similar mission planning options. On the Flight Hub 2 side, you have your options of live streaming, aircraft info, live 2D mapping, panorama, media upload, and mission planning. So if you need a refresh on Flight Hub 2, feel free to circle back to one of our previous trainings on that side. DJI Terra can import images taken by the M3E or the M3T for 2D or 3D reconstruction, or you can do them both. M3T on the mapping side, once again, is not recommended if we're looking to do survey grade mapping due to unreliable accuracy. But if we're more focused on getting situational awareness of a scene, 2D for the 2D mapping side, or even general 3D model, you obviously certainly can do that. Both the 3E and the 3T include a 3 months, 3-month DJI Terra electricity version license. And that's going to be automatically activated when the drone is activated. So if you haven't given Terra a try yet, and you have a Windows computer with the proper specs, would certainly encourage you to see what Terra can do. Some of the models from there are quite impressive. And then finally, DJI Thermal Analysis Tool 3.0. allows you to create a report, manipulate that radiometric thermal data, and that's supported at launch. On that thermal analysis tool side, I think there's been some good improvements made from my view, especially adding text onto the image and kind of the view and background. So appreciate user feedback overall on that as we continue to improve. Another great thing here with the Mavic 3 Enterprise series I know a lot of folks are excited about is MSDK support at launch. So it supports third-party apps running on the controller itself. So that is Android-based system, and that supports our Android v5 SDK. PSDK is not supported at the time of release, but we'll add that in future firmware updates. Maximum payload weight there is 130 grams. The Mavic 3 Enterprise series is really overall our first smaller drone with PSDK support. So really excited to see what our developers will do. I know we have folks working on a spotlight side. That's something of interest along with some different accessories. And then finally, Cloud API is supported as well. If you're not familiar, that's how you would interface with our DJI dock system, but it also interfaces directly with Pilot 2, including Matrice 300, Matrice 30, and the Mavic 3 Enterprise series. So you can get important information through that cloud API, such as live video feed, photos, telemetry, if you'd like to add that data to your cloud platform and not have to build a mobile app. So obviously MSDK is there for a lot of great use cases, but if you're looking for a lighter lift on the development side while still being able to get key data, Cloud API is very useful on that end. So more information on all of this on our developer website. So getting into regional restrictions and what's in the box. Few different regional versions here. We have the China version that can only fly in China. We have the NA version that can fly anywhere except China. Same deal with the general. And then the demo unit, which does not have flying area restrictions. And then you see at the end of those different regional versions, we have AC there. So that just includes in regards to how many different power cord options are going to come with that. So with the NA, just comes with the one plug for the NA market. General side, 6 different plugs, and demo side, 8 different. So that clarifies, hopefully for you, what the different regional versions are. Getting into what's in the box, you have the aircraft, battery, SD card, gimbal cover, propeller, 3 pairs, RC with the standard charger, 100 watts, the AC adapter, the USB-C cord, dual USB-Cs as well. And then packaging side, optional additions would be the RTK, the speaker, the charging hub, the extra battery, and 4G dongle, and then battery set is an optional add-on as well, and that comes with 3 batteries and 1 charging hub. So you can flip this here to see a picture of what comes in kind of your generic box. So you have your 100-watt inverter, plug, USB-C, side the aircraft, and 3 sets of propellers. Switch back one more time so you can kind of see that is the standard package with 1 battery. If you want the additional hub where you pull in, be able to charge multiple batteries, put multiple batteries on, that is an additional add-on option for the optional side. All right, so hopefully you have a good understanding of the Mavic 3 Enterprise series now and want to get into a bit of a product comparison. Obviously, many customers may currently have different DJI systems helping them out right now, or be interested in what the improvements are in regards to previous series if they're looking to make a decision between the two. So first off, comparing between the generic Mavic 3 and the M3E and the M3T. So first off, obviously shutter side with the M3E, you have the option for the mechanical shutter. On the app side, for M3E and M3T, you have Pilot 2, and you have the ability to do the different route planning. You have the waypoints, you have the mapping, plus some of the other options in Pilot 2, like the Flight Hub 2 connection, the Cloud API, all that good stuff. Minimum photo interval, M3E, we're looking at 0.7 seconds. M3T, we're looking at 2. And the Mavic 3, we're looking at 2.5 seconds. Thermal camera side, the Mavic 3E, obviously no thermal camera, same with the regular Mavic. The M3T is where you're going to get that thermal camera offering. Support of the mobile SDK, PSDK, and Cloud API. On the enterprise and side, M3E and M3T. Internal parameter calibration for the M3E and T. And then smart photography, such as time-lapse, point of interest, that would be something that's just coming with the Mavic 3 side. So more of the professional photographer side for the Mavic 3, the drones for work, mapping, surveying, inspections, etc. with the M3E and the M3T. So overall, hopefully that makes sense, kind of differentiating the products here. When we're looking on what we'd say more of a mapping drone here with the M3E and the P4R, you're going to have a much lighter and more portable system with the M3E. Very similar diagonal length when you actually unfold them, but obviously the M3E folds up into a much smaller package. Bit faster descent speed, higher wind speed resistance, which is nice with M3E, higher maximum flight time. Once again, comparing the M3E with the RTK module here. Operating temperature, -10 to 40 degrees Celsius. Maximum flight speed of mapping mission increased 2 meters per second there for the M3E. Max service above ceiling level, 6,000 for both. And then the propeller side, you can leave those on the aircraft with the M3E. I suppose it depends on the case for the P4R. But overall, M3E is going to be able to fly faster, work with higher winds, and also be able to transport that in an easier manner. Jumping in to the camera side, you can see the camera of the M3E is superior in pixel size when we compare minimum photo interval, the image format, and the 360-degree panorama image support. Adds the option for a tele camera for inspections or scouting as well. And then other modules here, improved obstacle avoidance with our advanced return to home, a pass 5 option, and really surrounding the bird there with the vision system. Getting into the RC and SDK, the M3E does have MSDK support, and I will say much easier for developers as well, as you may have seen already posts with folks supporting or having betas out for the M3E system, working with Android 10 and higher processing power on the RC itself. The added PSDK support, along with Cloud API, Flight Hub 2, and that RTK and speaker accessory. The RC itself, we're looking at farther transmission, HDMI support, a screen with a bit more memory there, and then different apps as well. So one thing we do want to note here is with the P4R that works with the GS RTK app. So you have a few different automated mission planning options that the M3E does not have. But that being said, we're excited with the MSDK support that you'll have even more route planning options to use as an end user if you need something along the lines of block segmentation, linear flight, or double grid. And we work to continue to improve the Pilot app as well with listening to end users. Moving over to the M3T compared to the Mavic 2 Enterprise Advanced system. So similar weight and size, obviously both Mavic platforms here, but when getting into the Mavic 3T, we start to see some additional ascent speed here, transmission range, the max flight time, a huge difference there with 14 additional minutes, the ability to fly in the higher winds as well, quite important, and then expanded obstacle sensing as well. So overall, with the Mavic 3 T. You have a Mavic with a reinforced body for enterprise work. You have a longer flight time. And then getting into the camera side as well, you have that improved telecamera. So zooming is significantly improved with the M3T when working with those side by side. And you also have the wide half-inch sensor as well, if you're looking for more of a general overview for the scene as well. Specifically zoom, you're up to 556 hybrid zoom there, but I don't think that necessarily tells the whole story. Obviously, much better range with the M3T zoom. All right, so now we understand the product, we understand how it stacks up with some of the current systems that have been on the market. And now going to get into some use cases from across the globe. So that's one of the great things about DJI being a global company. We're able to work with end users in a variety of areas to test and verify the ability of our products. So first one here is the Hailuogou Glacier survey. So this, as you can see, is a typical marine low altitude glacier in China, and it needs to be studied year round to see what some of the changes of the glacier are. So traditional surveying would require 1 to 2 days to complete a full-scale ice survey with what we call low efficiency. The comprehensive topographic data is not going to be able to be obtained if the ice surface is hard to access. So very complicated situation when you're looking at a traditional workflow. And just looking at that photo point distribution map on the right side here, you can see what a challenge this glacier presents. So the strategy that was used here was a layered shooting plan, and there was only 2 hours that were available due to the fog and rain in the area. So you can see a 1,500-meter section, a 1,000-meter, and a 500-meter section relative to takeoff points, and then was able to use terrain following through a historical digital surface model after checking the survey area in Google Maps. So this ended up being 9 flights in total, about 4,300, photos, and 11 and a half hours for the total modeling by Terra. Obviously, that could be slowed up or sped up depending on your computer configuration if you have multiple computers working together. But big advantage here, the M3E light and portable. Obviously, very difficult to use GCPs in this type of environment, flying up to 1,500 meters from the takeoff point, and overall high efficiency. Quick video here for you to see. Very cool. Just think about walking out on that with a handheld RTK. Does not seem like a fun job. So glad the Mavic 3E was able to help out here. You can see some of that detail too. Terry really does do a nice job on the 3D modeling side when you take a close look. Wow, cool view, cool view. All right, next up we have the Jiayu Pass Heritage Modeling. So obviously with large national landmarks, important to document that. So this is a little bit of a different use case than maybe many of you are used to. Route planning software was used where you're able to capture a general 3D model of the structure and then capture photos as close as 5 meters away from the tower. So close range photogrammetry. And this was 2 flights with 724 photos. The lightweight drone was a requirement with the density of tourists at the site and regulations. And then safety-wise, utilizing that customizable omnidirectional obstacle avoidance helped ensure safe flight, even just 5 meters away from the tower. Long battery life, allowed it to be 2 flights instead of 3. And then same thing with that 0.7 second photographing interval, able to take photos a lot quicker. Overall, this led to millimeter resolution, just being so close to the structure, and that integrated operation with the M3E and Terra working together. Another quick video for you all here. Just a beautiful 3D model. All right, next situation here we have was a orthomosaic taken in QINGXU. So overall, a land resource surveying need here. Very large size at 15 square kilometers with a 5 centimeter GSD. Complex environment, so not a ton of options for takeoff and landing, and quick data delivery schedule as well, just with 1 week to get that done. So they used a M3E, 9 batteries in total. Flight parameters was 150-meter altitude, which gave 4 centimeter GSD, flying at 15 meters a second. 10 sections overall for the route design with 80/70% overlap front side. And then it was able to complete data collection in a single day with 15 flights with almost 10,000 photos. So quite the data collection here. But when we think about it here, the real value of the Mavic 3E is obviously the efficiency, being able to fly so fast, and then the ability to not use GCPs, which really shines through, especially the bigger the site is as well. Just not having to place those GCPs out there and being able to use checkpoints as well. So you can see some of the GCP free aero triangulation accuracy here at 3.2 centimeters horizontal and 7 centimeters vertical. Once again, the O3 plus enterprise transmission, important to use. Also 4G image transmission utilized as well. Once again, not available quite yet for the general public firmware release, but that will be coming for markets outside of the US. FENHE River, a long distance inspection, is our next use case here. So more of a linear operation. So you can see about 4 flight lines on the right side. Once again, typically, if you just have 1 or 2 flight lines, you're usually going to run into trouble. So good to see 4 from this survey. Once again, another tight schedule and a long linear inspection that was required. So very similar to our last thing, just a little bit lower altitude, 120 meters, which gives us about a 3.2 centimeter GSD. Overall, used linear mission planning, 5 different routes, 300-meter width, and data collection was 7 flights in total with 8 home points per day. So overall data stats looking at 90 gigs of data and about 8,500 photos. Getting into the results, overall faster, stronger, quicker. I feel like that could be a new song here, but specifically referring to the Mavic 3E, and you can see some of that data there on the right side, utilizing some of the important parts of the Mavic 3E there, the speed, the transmission, and the ability to quickly take off and connect to RTK. If you haven't done it before, just a reminder with M3E, M300, M30, one of the nice things is you can take off and then turn on RTK if the specific takeoff area you're at may be struggling to get a strong GNSS signal. G20 highway inspection. So once again here, looking for surface and slope modeling at 3-kilometer length and at least 2 centimeter accuracy. And this is going to be a repeated data collection that we're looking at. So able to use the M3E and a smaller number of batteries. Data collection of 3 flights took about 2 hours to complete, and 3,500 photos. But overall here, specifically looking at highway maintenance and a specific refined model, which is covering a 500-meter extension on both sides of the highway itself. So you can see a nice video of the model there on the right at 2 centimeter resolution with some really nice coloring and the ability to identify the surface and any cracks in the slope. Obstacle avoidance, very useful with some of the different obstacles that you can see there on the right side, be changing terrain, and then the ability to capture accurate data at a fast rate of speed with the ability to process in DJI Terra as well. So once again, kind of compared to close range photogrammetry, once again, not as much of a level of detail needed, but you can still see quality 3D model. Another 3D model requirement here is the Southern Nanning 3D survey of the area. So looking at 10.5 square kilometers with a end goal of the 3D model as well. So on this side, the data collection was synced to Flight Hub 2, and they also were able to live stream in the cloud. So Program Manager was able to track work as it was going on. You can see some of those operations taking place. And then at the end of the day, they were able to do that 3D model presentation within Flight Hub 2 and then generate a digital line graph with some third-party software. Quick note, the 3D model uploading is planned to be supported in the first half of next year on the Flight Hub 2 side, but a little preview for you all as part of this project with the Mavic 3E. We have another close range photogrammetry survey here. This one was actually post-disaster in BAOXING. There was an earthquake, and this main disaster area was surrounded by mountains. So very tough to access with a very dangerous situation. So they collected overall data with the P1 and M300, and then did a survey of the area with the M3E based off of the P1 model. So about 1,200 photos for each disaster site and 30,000 photos in total. And overall, in this disaster survey, we're looking for different issues that they did not want to necessarily trek for on the ground. So they used software called Waypoint Master for about 10 to 20 meters of shooting distance. And then we're able to automatically capture hidden hazard points that they were not able to see without the drone. Obviously, the mountainous area is prone to lots of strong crosswinds and complex environment with different wires. So utilizing the omnidirectional optical sensing of the M3E was very important. So just showing one of the surveys here, and you can see just how close the drone is to the terrain there on the right side. Also, obviously, post-earthquake, not the most portable place to be. So having a portable drone, very useful, even if a vehicle that's larger is not able to access, easily able to carry the smaller drone. And our final case study on the AC and construction side with MCCOWN Gordon here. Overall, some of their needs here, monitoring job site progress over time and delivering updates to key clients within the product. So some of their key use cases include project updates, volumetric analysis, cut, fill, and grade analysis, and inspection of assets on site. And some of those challenges that come alongside that would be the large number of job sites that they work with, how big some of these sites are, and then that it's important to get that data. Construction things are always changing, so you need to quickly collect data and get that out to different stakeholders, even if the conditions and environment is not ideal. So some of the benefits they saw with the M3E included the ability to speed up capture time by over 200%, complete a 25-minute survey and still had 35% battery left, even in challenging conditions. And then also very happy with the image quality on the Mavic 3 Enterprise, sharpness, dynamic range, and exposure, specifically compared to the Phantom 4 RTK. Excuse me. So excited to see some of the progress there from MCCOWN Gordon testing out the Mavic 3E. On the power grid side, good to see some of the use cases for the Mavic 3T in this case. So you can see ability to read the pylon serial numbers, inspect insulator strips, utilize the zoom camera. We have a quick video here. So once again, green box shows what the zoom camera is looking at. We can fly, move over to the zoom camera, focus, adjust brightness, and capture data as needed. And then also utilize the thermal camera for any anomalies, whether that's wire clamps, cutter gates, or other possible hazards. Those pop out on the thermal view or through the use of something like temperature alarm. Benefit here compared to their previous workflow, obviously, is being able to stay at a longer standoff distance and not necessarily needing to fly within the span of the wires. So huge plus on the safety side with the combination of that wide camera, zoom camera, and thermal. PANZHIHUA power grid inspection, another use case as well. So this is a mountainous region with average altitude of 2,000 meters. So big challenge for UAV inspections and overall efficiency. And the point of the test they did here was kind of essentially comparing what they were using before with what's new. So with the Mavic 2 Enterprise Advanced, they're looking at 1.8 pylons per flight, and the M3E 3.5 pylons per flight. So with the battery life of the M3E being about 50% longer and the focusing speed being improved, obviously that led to a improved efficiency when they're looking at the number of pylons that they could inspect. So check that out on the right side as well. Some of that close range inspection that was required for their work here. They wanted the wide camera photos in this situation, and also have inspector on site with the drone itself taking a look there. So different companies, different approaches as well on the power grid inspection side, but good to see efficiency improvements for both. Looking at public safety side now here with the Mavic 3E, PEARLAND Police uses drones for accident reconstruction. On the accident reconstruction side, when an accident has occurred, officers do need to quickly document the scene oftentimes, especially in regards to an unfortunate fatality. But time delays in this process can result in potential crashes from the backed up traffic, other officers at risk standing in the road, and overall loss on the commerce side for the region, with drivers stuck in traffic, unable to get to work, unable to deliver, etc. There's obviously commerce losses as well. So opening up roads faster through drones for accident reconstruction. There's been multiple studies done on this use case, and when done efficiently and correctly, there's really some good results, and PEARLAND Police is definitely a leader in this space. So some of the benefits they're seeing with the Mavic 3E in their testing would be that option to utilize the RTK module for corrections. So there's an ability to use a few checkpoints instead of multiple ground control. That 0.7 second photo interval, 15 meters per second max speed, and the overall higher resolution allow the data collection to be quickly completed. And then also ability to process the imagery in DJI Terra provides an accurate 3D model to document the scene. So you can see on the right side here, PEARLAND PD workflow is capturing overview photos of the scene and then manually flying a few orbits while taking a few photos on the way down in a ladder strategy is PEARLAND Police Department's data collection strategy here. It leads to some great 3D models during the day and at night when they're seen. On the nighttime scene, they do manually capture the data just because they want to make sure the drone stops for the photos for that longer exposure time. But during the day, obviously able to keep the drone moving. So great continuing to learn with and work with the PEARLAND Police Department on the accident reconstruction side. Another use case, obviously, for law enforcement is deploying the drone for patrol. Obviously, a lot of deployments do happen at night, and the thermal camera is a big benefit there. So in this use case here, officers were dispatched based on a report of a catalytic converter, saw the suspect flee into the woods. Additional teams were there to try and set up a perimeter around the area, but they also needed to determine if the suspect was still within the wooded area that they submitted or set up the perimeter for and where they were. So one of the arriving officers was able to quickly deploy the drone from the back of their patrol vehicle before the suspect got too far away and utilize some of the thermal tools with the Mavic M3T, including the isotherms, the temperature area box, and the temperature alarm, and were able to locate the suspect hiding. So obviously different tools there and need to be comfortable with the tools there for the jobs, especially isotherms that can determine what's going to show on your screen specifically, but glad to have those tools for operators. Overall, the longer flight time as well was quite useful for the operator. Obviously, there's times where you have to come back and swap the battery out, so being able to stay in the air a bit longer, very useful between those battery swaps. And then also the ability to drop a pin, as you can see, is now an option with the Mavic 3 Enterprise in the top left there. So fly over, and that pin is placed with the location of the drone. So when coming back for a battery swap, can easily fly back to the location that they were at from before. Few FAQs following our use case section there. Does the M3E use a Hasselblad camera? So the camera's specification is the same as the Mavic 3, but with the addition of the mechanical shutter. Unlike the Hasselblad natural color solution used by the consumer, the M3E focuses more on the modeling quality, so M3E does not use the Hasselblad natural color solution. M3E does support TimeSync 2.0. A few items that are not supported, but do want to let you all know as well. High-res grid photo, battery self-heating, the dual control not supported, the Mavic 2 Enterprise Series accessories are not supported, and the yaw angle of the gimbal is not supported through the RC as well. M3E and T side, in regards to PPK, the M3E supports saving those files for PPK. That's would require third-party software for that PPK processing. The T does not. DRTK2 mobile station is supported. You put that in mode 5, broadcast mode, to connect to the Mavic 3 Enterprise series. I think that covers most of the questions, and a few of those are review from earlier slides as well, just important points to note. Continuing here, the M3E series support for Mode ID in US. Yes, that will be supported via firmware updates, and you can see the M3E and the M3T in the Federal Registry as well. Does the M3E series support AirSense ADS-B in? Yes. Turning the beacon on. In the camera view, you're going to go to the 3 dots in the top right, then the 3 dots in that submenu, LED settings, navigation beacon on off, that beacon built into the aircraft. Obviously a nice improvement as well, where you can add the different modules on top. And then another key point here is saving photos for the M3E and the M3T. For the M3E, you can only select to save wide or zoom photos and cannot save zoom and wide at the same time. For the 3T, you can save the current view, the visual camera, which will be the wide or the zoom, and infrared at the same time. Current view saves photos taken with the current camera, and it can also save a screenshot of side-by-side mode. So once again, the visual camera is just going to take whatever one you have selected, whether that be the wide side or the zoom side. Finally here, I want to cover the DJI Care Enterprise and maintenance program. First off, for Care Enterprise, we have our Care Enterprise Basic and Basic Renew, and then Care Enterprise Plus and Care Enterprise Plus Renew, and then also a 2-year DJI Care Enterprise plan. So obviously you can see the service periods there for those different options, the regular being 1 year, the Renew being the 2nd year, or the Enterprise Basic 2-year plan for 2 years. The service that goes alongside those and the covered areas. DJI Care Express is just an option for the DJI Care Enterprise Basic, and the covered parts would be the aircraft body, camera, the gimbal that's bound with the current aircraft, propellers, battery, and the DJI RC Pro Enterprise. And in regards to additional service that's included, that would be 1 free maintenance service. Japan, that's going to be 1 free basic maintenance service. Other regions, 1 free standard service. And a couple regions where that's not provided in regards to the aircraft itself for Korea and Hong Kong. So you can see overall kind of the different different care options. We'll get into maintenance shortly. DJI Care Express, if you're not familiar with that, just a quick review. It allows you to, as the user, to skip the damage assessment. So pretty much when you're sending in, you're saying, hey, this was my fault. I don't want you to do a data analysis on it. Just get me a new unit out as fast as you can. So when you do the online repair request, you have the option to select the DJI Care Express. So as soon as the damaged product is received, the replacement unit will be shipped out. Payment confirmation is required as well. Nice thing, just a reminder, within the DJI Pilot 2 health management system, you can purchase, bind, and use the DJI Care Enterprise Series plan. So you'll see in the top right, you can see number of days and the current status. So if the device has been bound with the Enterprise Service Plan, the expiration date will be shown. And if that's expiring, it'll say expiring in X number of days. And then if it is expired, it will then prompt you to go into the DJI Care Enterprise module when it is clicked. Within the Care module, you can go ahead and activate service, contact DJI, activate and bind the DJI Care Enterprise, DJI Care Express, repair service, all of that useful information. So once again, able to access that and see the current information from the health management system, very useful. On the enterprise maintenance side, we have the basic, standard, and premium. Those are recommended, once again, generally speaking, depending on the device condition, the 300 hours of flight time or a year, and then 600 hours of flight time or 3 years. Once again, being able to get those parts replaced and having a set maintenance plan in place, very useful for the longevity and life of the aircraft itself. Options there. Once again, the maintenance plan is the one shown on the left side, and then there's an option for the maintenance program, standard service, premium service, and you can see the different days and numbers of flight time there as well. So good to have all those details within the application to keep up on. Thank you so much for tuning into the training. Hope you have a good understanding of the Mavic 3 Enterprise series. Always here for questions and assistance as well.